Are you ready to dive into the world of hacking? In this video, I'm going to introduce you to a powerful networking Linux command that every hacker should know. Whether you're a beginner in the world of hacking or an experienced pro, this command will elevate your skills to the next level. Get ready to learn a command that will allow you to explore networks, gather information, and uncover vulnerabilities like a true hacker. And if you haven't watched our last video that 40 basic Linux commands, you can check out that video. So grab your keyboard, because we're about to unlock the secrets of networking Linux commands. ifconfig. The ifconfig command is used to configure network interfaces on Unix and Linux systems. However, its usage has been deprecated in favor of the IP command on modern Linux distributions. Nevertheless, ifconfig is still available on many systems and is commonly used for viewing and configuring network interfaces. Let's see some common uses of the ifconfig command. To view your network interfaces, just type ifconfig. This command displays information about all active network interfaces on your system, including their IP addresses, MAC addresses, and other relevant details. To activate a network interface, ifconfig interface up. This command will activate the specified network interface. To deactivate a network interface, ifconfig interface down. This command will deactivate the specified network interface. You can set with whatever you want MAC address with this command. ifconfig interface HW ether whatever you want MAC. But don't forget to deactivate the interface before you change MAC address. After you change MAC address, activate it. This sets the MAC address of F0 to the specified value. While ifconfig is still widely used, keep in mind that its functionality is being replaced by the more versatile IP command. It's recommended to familiarize yourself with both commands, especially if you are working with modern Linux distributions. With IP, you can assign IP addresses, configure routing tables, set up policy routing, and manage virtual interfaces. This command is essential for advanced network configurations and is widely used by network administrators and system engineers. For example, to view information about all network interfaces, their addresses, and routing tables, use IP address show. The next is iwconfig. The iwconfig command is used to configure wireless network interfaces on Unix and Linux systems. It provides information about wireless interfaces, their current settings, and allows you to configure them. Like ifconfig, iwconfig is still available on many systems, but its usage has been largely replaced by the more modern iw command. Let's see some common uses of the iwconfig command. To view wireless interfaces like an ifconfig, just type iwconfig. This command displays information about all wireless interfaces on your system, including their names, wireless standards, signal strength, and other relevant details. You can set the ESSID by typing iwconfig wireless interface ESSID or network SSID. You can set the mode with iwconfig. Just type iwconfig WLAN 0 mode managed. This command sets the operating mode of the wireless interface WLAN 0. Common modes include manage for client mode and master for creating an access point. You can set transmit power. iwconfig WLAN 0 TX power 30. This command sets the transmit power of the wireless interface WLAN 0. The value is usually specified in dBm. Keep in mind that the iw command has largely replaced iwconfig for wireless interface configuration on modern Linux systems. The equivalent iw commands may vary, so it's advisable to check the documentation for your specific Linux distribution. The next is ping. The ping command is used to test the reachability of a host on an Internet Protocol network. It also measures the round-trip time for messages sent from the originating host to a destination computer. For example, ping hostname or IP address. This command sends ICMP echo request packets to the specified host or IP address and displays the round-trip time for each packet. You can specify number of packets by typing ping C6 hostname or IP address. This command limits the number of packets sent to the specified host or IP address to 6 or any other desired number. You can set time interval between packets by typing ping I1 hostname or IP address. This command sets the time interval between sending individual packets to 1 second. You can change the value as needed. You can use specific network interface by just typing ping I interface hostname or IP address. This command specifies the network interface to use for the ping operation. You can set timeout for each packet by typing ping W3 hostname or IP address. This command sets the timeout for each packet to 3 seconds. If a response is not received within this time, the packet is considered lost. The ping command is a useful tool for troubleshooting network connectivity issues and determining the responsiveness of hosts on a network. Keep in mind that some network administrators may configure their systems to ignore ICMP requests, which can affect the effectiveness of the ping command in certain situations. The next is NetDiscover. The NetDiscover command in Linux is a network scanning tool used for discovering devices on a local network. It works by sending ARP or Address Resolution Protocol requests to the specified network and then displays a list of active devices along with their IP and MAC addresses. This tool is particularly useful for network reconnaissance and discovering devices in your local environment. Let's see a basic usage example. Sudo netdiscover r IP range that. This command will scan the IP addresses in the range from 192.168.1.1 to 192.168.1.254 and display a list of active devices along with their IP and MAC addresses. Some additional options include IOR interface, specify the network interface to use for the scan. T. Enable promiscuous mode, allowing the network card to capture packets that are not addressed to it. Keep in mind that using network scanning tools should always be done responsibly and with proper authorization. Unauthorized scanning or probing of networks without permission is against the law and can lead to serious consequences. Always ensure that you have the right to scan or test a network before using tools like NetDiscover. The next networking command is traceroute. The traceroute command in Linux is used to trace the route that packets take to reach a destination host on a network. It provides a way to discover the routers or hops that a packet traverses from the source to the destination, as well as the round-trip time for each hop. Let's see basic usage example. Traceroute, hostname or IP address. This command sends a series of packets to the specified destination and displays the list of routers or devices that the packets traverse along with the round-trip time for each hop. Some common options for traceroute include N. Display hop addresses as IP addresses instead of attempting to resolve them to host names. This can speed up the traceroute process. Queue or queries. Set the number of queries to send to each hop. The default is 3 queries. Max hops. Specify the maximum number of hops before giving up. This can be useful for limiting the scope of the traceroute. Here's an example with additional options. Traceroute NQ5 max hops 20 hostname or IP address. This command will perform a traceroute to www.example.com without attempting to resolve hostnames, send 5 queries per hop, and limit the maximum number of hops to 20. Traceroute is a valuable tool for diagnosing network connectivity issues and understanding the network path to a particular destination. Keep in mind that some network administrators may configure their routers to not respond to ICMP packets, which traceroute relies on, so in some cases, you might not get responses from every hop. Additionally, the accuracy of traceroute results can be affected by firewall settings and other network configurations. The next networking command is netstat. The netstat command in Linux is used to display network-related information such as network connections, routing tables, interface statistics, masquerade connections, and multicast memberships. It provides a comprehensive overview of the networking activities on a system. However, it's worth noting that netstat has been deprecated on many Linux distributions in favor of the more versatile SS and IP commands. Despite its deprecation, netstat is still available on various systems. Here are some common uses of the netstat command. To display all active network connections by typing netstat A. This command shows all active network connections, including listening and established connections. To display listening ports by typing netstat L. This command shows all listening ports on the system. To display network statistics, just type netstat S. This command provides various network statistics, such as the number of packets received and sent, errors, and more. To display routing table, type netstat R. This command shows the system's routing table, displaying information about how network traffic is routed. Keep in mind that the exact options and output may vary depending on the version of Netstat and the Linux distribution you are using. As mentioned earlier, it's recommended to explore SS and IP commands for more up-to-date and feature-rich network information on modern Linux systems. SS is a versatile command for displaying socket statistics. It offers more detailed and up-to-date information than Netstat, and is particularly useful for troubleshooting network-related problems. With SS, you can examine socket states, filter results, and gain insights into the system's network activity. The next is TCP-dump. TCP-dump is a powerful command line packet analyzer tool for capturing and analyzing network traffic. It allows users to display TCP, UDP, and other packets being transmitted or received over a network to which the computer is attached. Let's see some common uses and examples of the TCP-dump command. To capture packets on a specific interface, type sudo TCP-dump I whatever you want interface. This command captures packets on the interface. You'll often need superuser privileges to capture packets on interfaces. To filter traffic by protocol, type sudo TCP-dump I interface protocol. This command captures only ICMP packets on the interface. To capture packets and save to a file, type sudo TCP-dump I interface w output.pcap. This command captures packets on the interface and writes them to a file named output.pcap for later analysis with tools like Wireshark. To display packet contents in ASCII, type sudo TCP-dump I interface a. This command captures packets on the interface and displays the packet contents in ASCII. To filter by source or destination IP, type sudo TCP-dump I interface host IP address. This command captures packets on the interface where either the source. To display port-based filtering, type sudo TCP-dump I interface port number. This command captures packets on the interface where the source or destination port is 80. TCP-dump offers a wide range of filtering options, and its output can be quite detailed. It's a valuable tool for network troubleshooting, security analysis, and understanding the traffic on a network. However, interpreting TCP-dump output may require a good understanding of networking protocols. Keep in mind that capturing network traffic without proper authorization may violate privacy and security policies, so always use TCP-dump responsibly and in accordance with applicable laws and ethical standards. Thank you for joining us on this journey through essential networking commands on Linux. We've explored powerful tools that can be beneficial for various purposes, from troubleshooting connectivity issues to optimizing your network. If you found this video insightful, don't forget to like, share, and subscribe for more content. And guess what? There's always more to learn. If you're hungry for additional insights into Linux networking commands or want us to delve deeper into specific areas, drop your thoughts in the comments below. Your feedback fuels our content, and if there's enough interest, we'll be more than happy to bring you a part 2. Stay tuned, stay curious, and keep exploring the vast world of Linux networking. Until next time, happy hacking and may your connections always be strong and secure. Cheers!